Okay, watch the birdies. I put this little piece in slow motion. Watch it vanish into its own reflection. I did slow this down to 0.33 to give you a little idea of what I'm talking about with the mirroring. My camera's usually, I try to keep it at about the same height. The camera itself is sitting up at 5.5 feet. I may be a foot off the water. If not, I'm right down at the edge of the water. And I wanted to just show you how these layers, these mirror layers are. And you can see it on certain days where the wind's blowing and it ripples in some areas and it's calm in other areas. And then I get the trolls tell me that the water is not mirroring the sky, which it's obviously it mirrors the sky. Because it is a mirror, because you can see it mirroring Bayport bird rack, and you see it mirroring the green channel marker to the left. You can see its mirror image being stretched out and distorted. That's another thing that occurs, is the distortion. It's just like being in a house of mirrors. And this house of mirrors can distort things. It can stretch things out, and it can compress things. And the reason it does this is because the water is not perfectly flat, but it does create this mirror due to my angular resolution, and the light hitting the water creates this effect. You can even see birds. You can see fish sometimes in my videos jumping out of the mirror and back into the mirror. And, again, science wants to say that it's refraction pulling things up. And it's pretty obvious on certain days. It's pulling things down, not up. And I have another little video coming up from a different day where I'm going to show you where I'm sitting on the shore. And then show you my view from a day with a little better visibility and without as much of the mirroring being caused. It's even like looking down the road. Again, you look at the water on the road, or it appears to be water. Well, that's a mirage. Well, what happens when you got a mirage on top of water that looks like water? It is a mirror, just like the water on the road. It is a mirror. It reflects things. So in turn, this is what I show with my key observations to show you how this works. And you can believe me or you can believe your eyes. Both, whatever. Okay, it's March 31st, 2018. And it's about 4:54 right now. And we got calm waters today. And I'm going to try to do some filming. And then hopefully I can do a time lapse, but wanted to show really kind of how close I was to the water. People always question that. So the tide is going out. I will try to follow it down the bank as it does go out, best I can. Alright, just wanted to make a little video documenting this, and even look at how that water is mirroring the light. Okay, here we go. I'm going to get my camera going here. Okay, in this little portion, you can obviously see all the horizontal boards going across this bird rack. There's 7 of them, including the top. But look at how the bottom board is actually being mirrored. That board is not that wide, and there is plenty of water underneath it. But again, it is mirroring. It is drawing that upper board, or the board at the bottom, downward, causing this mirror effect. So on this particular day, the mirroring effect wasn't as bad. But anything, like I say, that goes beyond this visible water is just mirroring the sky. And that's why if you look at the bottom of the boat and watch the painted areas on it get drawn down into that water, it's a good way to show this downward refraction. Um, and you know, that's something that a lot of people do overlook. It's starting to come out more and more. Um, some of the other observers are starting to really pay attention to their observations and see how this works. It's not an upward refraction, it's downward. So basically, you know, I look out there and I look at it as a house of mirrors. And, you know, then you also got to think about, again, those parallel lines, the sky being, um, you know, on a parallel line and the water being on a parallel line. And you're going to see way more of the sky than you are going to see of the water. So the surface of the water is a short distance where the sky is a large distance. So it's going to converge into the water at a short distance. And that also depends on my camera height. I lower my camera, the more of that visible water will block out more of that boat. Why? Because waves block things out farther away, because I'm resolving the wave that's closer to me than the wave that's far out in that mirage area, because you can't see it because it's in the mirror. I can't get it much plain or much more simple than that. And you know, you're watching this boat right here. You can see its markings going up and down. You can see that crab trap bounce up and down and get blocked out partially from the closer waves that are in front of it. That's another thing too. I've got some videos where I've got some crab traps that you know, I can see for a long distance, and you know, you can see how that water can block them out. The closer waves, the lower my camera gets to it. I need to show that one day. But I've got so many observational videos, it's hard to pick out what I want to show. Um, but I think all of it's important when you're really using your observations to determine what we're actually seeing. I mean, you know, you can actually see this guy's wake, the water being pushed up now, because he's not far off that visible water line. So he's right at the edge of going over the curve, I guess, or at least that's what they want to tell us. It's being pulled up from behind that curved water. But if you look at how mirrors work, especially in a house of mirrors, you'll start understanding this. So if you've ever gone to a house of mirrors, think back about what those mirrors did. And then think about if you were looking at them on an angle, you know, where they were laid down on the floor and you were standing above it or, you know, next to it, behind it, and somebody was looking at the mirror from an angle. You're going to get some really strange effects. You're going to get a lot of distortion. And that's what we see when we're out here on the water. Okay, I'm trying to give my camera a good focus here because I really want you to see this as I'm tracking this boat. And you see as the boat gets closer, he is getting a little bit bigger, but he's actually going into Hernando Beach Channel, and that's I'm going to say approximately 3.5 miles from me. And there's Billy Steele's, which you could see the mirroring going on in it, and I get different appearance of that. But look at this boat. Look how it is actually being drawn down into that water. It's being drawn into the mirror. and if you can't see this, then man, I swear you need to get your glasses checked. Now watch that. Watch this. Oh my God, water should be going into that boat, huh? But it's not. It's not going into the boat. Again, this is just how this mirroring effect works. Again, you're looking at this mirror from an angle, and your angular resolution is just causing this effect. It's just how our eyes work, and it's even how the camera works. Because my eyes, I couldn't even see this boat because it blended in so much to the background. You see how it's kind of grayish white? Well, that blends in to where my eyes can't see it. And look at this boat here. We can walk on water. I mean, everything's a reflection after that visible water line. And even look at the sign. You can practically read that sign because my visibility is good up to that point. But it's the mirroring that causes the distortion, these effects where it looks like this boat's below the curve, but it's actually just downward refraction, drawing the boat down, causing this appearance. Even these people, look. And then this boat goes by. Whoa. And just look at the clarity to the signs. Anything that's up above is not being distorted. That's high enough up for my camera to resolve. It's not getting distorted, unlike that area just above the water. It's just a little sliver. And that's why some days that mirroring is worse than others. And the visibility is really good on some days. And when I get that really excellent visibility, no wonder I can not only see Cutter's Rock, that's 11 miles away, with water beyond it, because that is one of what I call an excellent day of visibility. And you see this boat, and you see these channel markers. Those are Hernando Beach channel markers. And that little point there to the left, where the kayaks are at, that is Fiddler's Point. And look, the tide is high, and the water doesn't even go up as high as when I showed you it on a low tide. When I had better visibility, you can see that water go way beyond, or up. It appears to be up farther than everything. And this is where they get you, okay? Because it appears higher. They're telling you it's refraction that pulls it up. They're not telling you that it's visibility that's giving you the better view, because all of the videos that I do when I have good visibility, you can see the boats clearly in the water. And that's the difference. When you can see them clearly in the water, that refraction is not pulling it up. I mean, look at these boats. You can tell that refraction is actually pulling them down. It's dragging them down. It's causing this distortion. And that is why we got fooled. Okay? I was fooled. I always believed this boat's going over the curvature proved that we lived on a globe. But I can no longer say that once I started doing my research and my observations, and also being a kid, remembering going into the House of Mirrors and seeing how my body was distorted and also stretched. And I got to apply that to exactly what I'm seeing out here on the water, because that's exactly what's going on. But most people, they want to stay within that belief. I mean, look at this boat as it's rocking. I mean, and it's pulling the edges downward, pulling it right into that mirror. Come on, isn't it obvious if you use your eyes and you use your own common sense and you think about it, that what I'm saying has to have some truth to it, people. I mean, I'm not out here trying to deceive anybody. Matter of fact, like I said in the beginning when I first looked at flat Earth, I did. I thought it was a big joke, and I went out to debunk it. And man, what I found was totally strange for me, and I didn't even want to admit that I was wrong at first. And then it took me a little while to think about making videos and really exploiting this, but it was really hard to try to understand and explain, because you have to have the experience of being out on that water too. And I've been out on the water on some days where, again, I had great visibility, and even in my boat I could see those condos way down in Hudson, from Hernando Beach, from my boat. And it's like wow, I don't always see these buildings at this distance. But then I look around and I can realize that my visibility is great. And then I also remember, hearing the weathermen say that, you got a 10-mile visibility today. Wow, 10 miles? And I'm standing in my boat. And hell, I'm not even 6 foot tall. And when I'm standing in my boat is where I'm standing at. I'm almost standing on the water because my boat just sinks in enough to where the floor of my boat is at about sea level. Sea level. Should I say that again? Sea level. But it isn't truly level because we have waves and we have swells. And on my coast, on the Gulf of Mexico, we don't have the swells and the waves that you do on the East Coast. And on the East Coast, it's the mirroring effect is even worse. And that's why you say big ships going over the curvature of Earth proves that we got a curve, that the Earth is a ball. But I say basically from the time that I went to Cocoa Beach, that these ships were just being distorted and pulled down just the same as these smaller boats. So what would be harder to film? A smaller boat going out 11 miles or one going out, 20 miles as a big ship? The big ship, you're going to be able to see farther and longer because it sticks up so high. But it's that bottom portion that appears to be being blocked, but it isn't. It's being drugged down into that mirroring, and that mirroring is what causes everything to get cut off at the bottom. Same way with buildings. One day you'll see the Chicago skyline. Good Time for All. He's doing a great job with the Chicago skylines. He's been there doing a bunch of filming and really, really showing you how it's not really rising up out of, or rising up due to refraction. It's rising up because it's coming out of the mirror. And that mirror is what's dragging it down. So it's releasing it from its refraction and allowing you to see all the buildings, or damn near all of them, because you're always going to seem to have this little refraction line just at that edge, depending on the visibility of your day. Now, I don't think I've ever heard of the weatherman said you have 20 miles of visibility, but you would if the building's taller or tall enough. You would see the tops of these buildings at 60, 70 miles. I can get the Crystal River Power Plant from Hernando Beach, and that's quite a few miles away. I think it was either 30 or 40 miles. So, just think about what I'm showing you with this mirroring effect and how it does affect our vision, how we would view it on an angle. And just think for yourself, people. I'm not trying to get you to believe me. You don't have to believe me, but you should believe your eyes to a certain point. Yes, we can be fooled. You got an illusionist doing an illusion. Yeah, he can fool you. But one thing I know: if I go to a magic show, I know I'm going to be tricked. I know it's going to be a fakery. It's going to fake my eyes. And what do they use? Smoke and mirrors a lot of times to do these illusions. All right. So take that into consideration. All right. Thanks for watching my long ass videos. Like, subscribe, and share, please. I really do appreciate you.